Okay, hello everybody. So let's go ahead and get started. We are going to be talking about functions today, more specifically, what a function is and function notation. So just go ahead and write your name. And y'all, if you have multicolors and you want to use that, that's fine. But if not, just pencil or pen. So first of all, what is a function? Let's try to go back to elementary in our heads, and you might have learned about a function machine. So the name of this function is f. When my input is x, so when x is the input into the function machine, what is going to come out of this machine has to be a specific y value. So for every x input, I'm going to get only one y value. So this is good. This is what a function should look like. Okay? So a function is when each input of x has only one output or one y. Now let's do a bad example, what it's not supposed to look like. If an x value is matched with two or more y values, it is not a function. What does this look like? Well, this looks like if I have a function machine where x is getting inputted, but then I'm having multiple, let's call this A, B, right? I'm having multiple different outputs. That is not okay, not a function right here, okay? Vertical line test is, so if a vertical line touches a graph more than once, it is not a function. And we're going to see what that looks like right now. So let's actually go over the vertical line test first. So coming down to right here, this is kind of like a mini anchor chart. So coming down over here, we can see some vertical line test happening here. So here we have this line right here, this one right here. On this side, we have an example of yes, this is a function, because if you look closely at this vertical line that they did right here, all the way down, the vertical line only hits our graph one time, or our original line one time. So this is good. This means that for this input of x, we have one y value as an output. But let's look here. When we do the vertical line test on this line, I'm touching the line right there, and then I keep going, and I'm touching it again. So that means for this x input, I have two outputs. And like we said earlier, this is not a function, right? So the vertical line test is kind of just a shortcut, like look, boom, boom, not a function. Hits it just one time, good, that is a function. Now let's move on to a table. When we have a table, here's our example of yes, a good function, or a function. We have no repeating x's, okay? And if we did have a repeating x, let's say -1 repeated, it should have 3 as an output. But they really probably won't show it to you like that on your test. So if you see no repeating x's, that is most likely a function, or that is a function. And we can see like every input only has one output. -3, if you put it in the function machine, gets 3 only. 0 gets 5 only. 1 outputs 7. 2 outputs 9. However, when we look on the right, we're seeing an x repeating. That's already a sign of it's probably not a function. And I'm sure it's not a function because -1 outputs 3, but then here it outputs 5. So that's as if -1 was entering into the function machine and outputting a 3 and outputting a 5. And that would just not be a function, right? So this one's not a function. We really won't see mapping like this, but this kind of just helps some visually. So we're seeing like the input of 4 having 2 outputs. Like that's not okay, right? And then this one, you only see one arrow coming out of each of them, so you know each of them is only having one output. And I want to point out really quickly, like, it is okay for y to repeat. It's okay for 4 to have an output of 5 and 3 to have an output of 5. It's just not okay for the x to repeat. Okay, so 4 can't have two different outputs. Now let's look at the ordered pairs. So here we have a function. I can see already like no x is repeating. This 2, I don't see it again. -1, I don't see it again. 0, I don't see it again. 1, I don't see it again. And they all have their just one output. So this one's good. This one is a function. But then when I look here, I see that this x gets repeated. And here it's outputting a 5, while here it is outputting a 9. So this is not a function. Okay? Oops. There we go. If y'all feel like you need to watch this again, pause it and watch it again. Take any notes that you need before moving on, because we are now going to talk about function notation. Okay, so this is how to tell, is it a function or not? And now we're going to go ahead and move on to function notation. So let's go to the top. Oops. Erase this, giving you the answers. Okay, so evaluating a function. To evaluate means to substitute the x value and find y. So basically just like replacing the x value with a number and then solving for y. Notation. So here's our function notation. F of x equals y. And then we have an example. If we had f of 2, here we're substituting the x with a 2. That means when x is 2, what is y? And now our steps for success for evaluating a function are: find the input, which is the x, on the x-axis, and then move up and down to the graph, and read the y value, that is f of x. If this did not make sense to you, that's okay. Here's a visual. And I'm going to go over a table now, and then in the practice problems, I'll go over a graph. So here is actually just function notation. I told y'all earlier, like with the function machine, that f is the name of the function. So if we were to write it like a function machine, if that helps you, we have f, that's the name of the function. And then we have x, which is the input. And then we have y, which is the output of that function machine. Okay. Sorry if you can't see the colors too well. I tried to color code it over here. So let's see what that means for us in a graph. In a table. So here we have a table. And remember, this is f of x equals y. So f of x when x is 0 equals 2. Because when x is 0, my y is 2. So let's try to make another one, and I want you to actually pause this video and try to make function notation for this point. And then unpause it and let's do it together. So pause. I hope you actually tried that. But if not, or if you did, let's do it together. So f of x, right? This is where the x is going to go, of 1. Equals, well, our y, when x is 1, our y is 4, so equals 4. So that was pretty easy, right? So pause again and try to do it for this point. So go ahead and pause. I hope you paused. Now let's do that one. So f of x, and here our x is 2, so when x is 2, our y is 6. When x is 2, our y is 6. So this is kind of how it looks like for a table, and then we'll see how it looks for a graph later on, but it's pretty much the same thing, okay? So now let's go ahead and switch into our practice problems. Here's our first one. So it says, which table represents y as a function of x? Y as a function of x is basically just asking you which one is a function, okay? So we're looking for which one is a function. And if you want to try this on your own, just pause and then you can skip to when I show the answer to see if you're right, but if not, just follow along. So which table represents y as a function of x? Meaning when x goes into our function, we have only one output. So let's see. -5 has an output of -5. Do I see -5 repeat? Yes, I do. And here it has an output of -5, and here it has an output of just 5. So if that was a function machine, when -5 goes into the function, it's outputting 5 and it's outputting -5. And this is not what a function is supposed to look like, right? So this one is not a function. Now, I'm not going to do this moving forward, but this is something that you can do if the visual helps you, okay? But I'm going to try to just make it a little quicker than that. So let's see if our x repeats. Does 6 repeat? No. Does -6 repeat? No. Does 8 repeat? No. Does -8 repeat? No. Which means that this is a function. Okay? Because none of my x's repeat, so I know that they all have their own unique output or their own pair. So let's look at this one just to make sure that we didn't make any mistakes. Does -3 repeat? Yes, it does. -4 and 4 are not the same, which means it would look something like that. So it is not a function. And let's look at this one. Well, I can see like 2 just keeps repeating. And it keeps having different outputs. So this would be like if 2 had 4 different outputs. And we know that's not a function because every input should have only one output. And this one has 4, so this is not a function. So it looks like we got our answer, and it is G. Now let's look at 2. So we have graphs here. So we are going to do the vertical line test here. And I'm going to use a red just because that's what I'm used to using. I think it'll be easier to see on the camera as well. So let's get a little, yeah, that looks good. Okay, let's start our vertical line test. If I do my vertical line test here, well, it's only hitting at 1 point. So let's try it somewhere else. Let's try it here. Okay, 1. 2. This is not a function because the input, if you can see right here, this is -3. So when x is -3, it's having the output of 5 and the output of -5. So you don't need to go into this great detail, but I'll show you real quick when x is -3 and it goes into the function machine. It's having the output of both 5 and -5. So this is not a function, right? Because we shouldn't have 2 outputs for 1 input. So that's pretty much what the vertical line test is doing. So from now on, I'm going to just stick to the vertical line test and not show all that, but hopefully that's like staying in your mind for the reasoning, right? So let's try the vertical line test here. I'm hitting it 1, 2, and 3 times. So not okay because for the input of -4, having 3 different outputs when I should only be having 1 to be a function. Now let's try this one. Let's just pick any random spot. 1, 2. So again, not a function because the input of 4 is having 2 different outputs. And let's try our vertical line test here. We hit it 1 time. 1 time. So this one's looking to be pretty good. 1 time, and so on. So this one would be our answer. And I know it's still like what, but it's like such a squiggly line. But hey, look, the vertical line test shows us that this is a function. If it was like this, then it wouldn't be, right? Because we would hit it too many times. But this would be a function. Now let's turn to our last question, question 3. And I'm going to tell you right now, you're going to see a question almost identical to this on the test. So I hope that you really internalize this and understand it. So I'm going to write just real quick function notation so that we don't forget. F of x equals y. So here we're saying a graph of y equals f of x, which is the same as f of x equals y, is shown. Find f of negative 6. So if I were to write this right under function notation, it would look like this. And sorry if you hear my dog. F of negative 6 equals, so obviously we're trying to figure out what is y when x is negative 6. So I'm going to look at my x-axis. Here's my x-axis. And I want to know when it's negative 6 on my x-axis, what is my y? So we come up till we hit the line. And then let's see, what is the y? The y is 5. So our answer would be D. If you need to rewatch this, rewatch any piece that you need. Because once you start the independent practice on EdSite, you will not be able to go back to the video because it has locked down browser. Okay? So if you need to rewatch anything, take notes on anything, do it now. But if not, you are done with the video and you can move on to EdSite.